Find the Laplace transform of each of the following functions. So in part A we have t times e raised to 3t. So in part B same thing, t times cosine, and part C t squared times something. And here is the formula. When we have t raised to some power times a function, then the Laplace transform will be -1 raised to n. It's just t means -1 raised to 1, -1, and we find the Laplace of f, which is uppercase f, and take the nth derivative. Okay, it's like t squared, take the second derivative of the Laplace transform of f, and -1 raised to 2. So in this question here, we need to find the t times means the Laplace transform will be then, looking at that formula, -1 raised to t means t raised to 1, just 1, and find the Laplace of e raised to 3t from the table, which is 1 over s minus 3, and 1 means we want to take the derivative just one time. Take the derivative with respect to s just one time, and that happens now. -1 raised to 1 is just -1. Now the derivative of 1 over s minus 3 is like 1 over u, that's -1 over u squared, s minus 3 squared. Negative, negative, positive, so this is 1 over s minus 3 squared. Okay, the particular table, Laplace transform table, might have direct formula from here to here. T times e raised to 3t directly there. Okay, and next same thing here. Now the Laplace transform will be, we find the Laplace of cosine 2t, and t raised to 1 means -1 raised to 1, and take the derivative just once, one time, of Laplace of cosine 2t. Looking at the table, cosine of 2t has Laplace transform s over s squared plus 4. Now let's find the derivative using quotient rule. That's -1 raised to 1 is just -1. Using quotient rule, we get on the bottom is squared. On the top, derivative of top is 1 times bottom minus derivative of bottom, that's 2s times s, 2s squared. Let's simplify this. So this is s squared minus 2s squared, so -s squared, and we need to distribute by negative, so that's just positive s squared, and this is 4, this is -4 over s squared plus 4 quantity squared. Let's move to the third. Now this is t squared sine 3t, so the Laplace transform will be -1 raised to 2, and double second derivative, we need to find derivative twice of the Laplace of sine 3t. And look at the table here, sine 3t has the derivative 3 over s squared plus 9. Now we need to find the derivative twice, and outside -1 squared is just +1, don't have to write. Let's find the derivative here. It's like, we can pull 3 outside, by the way, 1 over a function u, and we know the derivative of 1 over u, that's -1 over u squared times u prime. Okay, and we need to do twice, by the way. So we get this 3 outside, 1 over s squared plus 9 is now, and we have to do one more time, d over ds, one derivative, 1 over u is -1 over u squared, s squared plus 9 quantity squared times derivative of s squared plus 9, which is 2s, that goes on the top. Okay, let's do one more time, and we can pull this -2 outside, that'd be -6, and derivative with respect to s over s squared plus 9 quantity squared. and let's find the derivative. The negative 6 already outside. Now we need to use quotient rule because we don't have constant anymore, and using the quotient rule, on the bottom we have bottom is square s square plus 9 square fourth. On the top, derivative of top, that's 1 times bottom, s square plus 9 quantity square. Okay, let me write over here, I don't have room, so let's go down here, minus, okay, derivative of bottom, that is 2s squared plus 9 raised to 1 times derivative of inside 2s times the top is yes. So let me simplify over here. So pretty much we were finding the derivative of this fraction using quotient rule. So negative 6 outside times, on the bottom we had s squared plus 9 to the fourth, on the top s squared plus 9 squared, so 2 copies of s squared plus 9, and second term has, this is 1 copy of s squared plus 9, so we can factor s squared plus 9 out. That leaves 1 copy of s squared plus 9 on the top, minus, this is out, so 2 to 4 s squared. Okay, we don't have to write parentheses. Now we can simplify. Look, 4 copies, 1 copy, we can cancel, and leaves 3 copies on the bottom. S squared minus 4s squared is negative 3s squared, and we need to multiply by the negative 6. So I want to write down negative, just multiply by negative 6 outside, s squared minus 4s squared, negative 3s squared with negative, just 3s squared, and positive 9 with negative 1, negative 9. We could have factored 3 out in the next step, but that's not needed. 3, and this is the Laplace transform final.